Welcome to another session. We shall take up today few important trigonometrical identities. Let's start. First question: prove that cos square A plus 1 upon 1 plus cot square A is 1. We have to prove that this expression is equal to 1. Let's see the solution. First, take left hand side, which is cos square A plus 1 upon 1 plus cot square A. This is our left hand side. Now, in next step, I will convert this cot square in terms of cos square A upon sin square A. As we know that cot A is cos A by sin A. Now, in the next step, we will further simplify it as cos square A plus 1 upon this becomes sin square A. This is sin square A plus cos square A, and the next step we can write the same thing as cos square A plus this sign will go up. This is sin square A, and this is sin square A plus cos square A, which is 1. Now again, this is cos square A plus sin square A, which is again 1, and which is nothing but our right hand side. So it is proved. So the identities are very important, and in exam you are surely get one question from this part. Let's take the next question. Prove that under root of 1 minus cos theta upon 1 plus cos theta is equal to cosec theta minus cot theta. Now for solution, take left hand side, under root of 1 minus cos theta upon 1 plus cos theta. This is the left hand side. Now here we will multiply numerator and denominator by 1 minus cos theta and 1 minus cos theta, which is nothing but 1. So doesn't change the expression. Now next step, 1 minus cos theta times 1 minus cos theta becomes 1 minus cos theta the whole square, and denominator 1 plus cos theta times 1 minus cos theta is 1 minus cos square theta. Here we have used a plus b times a minus b is a square minus b square. This identity we have used here. Now the next step, we can write this numerator as 1 minus cos theta the whole square, and 1 minus cos square theta is nothing but sin square theta. Here again we have used cos square theta plus sin square theta is 1. So 1 minus cos square theta is nothing but sin square theta. This identity we have used in this step. Now since these are perfect square, I can write it as 1 minus cos theta, and this square root sign, it comes out of it, and this is sin theta. The next step, we can write it as 1 by sin theta minus cos theta upon sin theta. Now 1 upon sin theta is nothing but cosec theta minus this is cot theta, and this is nothing but our right hand side, hence proved. So these are some of the important questions and which are surely asked in the exam. Let's take another question quickly. This is question number 3. Prove that sec A times 1 minus sin A bracket sec A plus tan A is equal to 1. Again, let's start the solution. Take left hand side, which is sec A times 1 minus sin A bracket sec A plus tan A. This is our left hand side. This we can write as sec is nothing but 1 upon cos A times 1 minus sin A, and this is 1 upon cos A plus tan is sin A upon cos A, bracket close. In the next step, we can write it 1 on cos A bracket 1 minus sin A and bracket, in denominator it is cos A and in numerator 1 plus sin A. The next step will follow 1 by cos A 1 minus sin A bracket 1 plus sin A upon cos A. In next step, A minus B, A plus B. Same identity we will use. This will become 1 square minus sin square A upon cos A multiplied by cos A will be cos square A. Now 1 minus sin square A is nothing but cos square A upon cos square A, which cancels to give us 1, which is right hand side, and thus we have proved the identity. Let's quickly take another important identity. This is question number 4. Prove that cot theta minus tan theta is equal to 2 cos square theta minus 1 upon sin theta times cos theta. Now once again, we will consider the left hand side. Left hand side, which is cot theta minus tan theta. This can be written as cos theta upon sin theta. As we know, cot theta is cos theta upon sin theta, and tan theta is sin theta upon cos theta. In the next step, we will just take the LCM, which is sin theta multiply cos theta, and this will become cos square theta minus sin square theta. Now, making use of the identity, in the next step, cos square theta minus, instead of sin square theta, I'll write 1 minus cos square theta. As we know that sin square theta is equal to 1 minus cos square theta. So I have put in place of sin square theta 1 minus cos square theta, and in denominator it is sin theta times cos theta. Now, in next step, this becomes cos square theta minus 1 plus cos square theta upon sin theta multiplied by cos theta. And the next step, cos theta, cos square theta and cos square theta are added up to give 2 cos square theta minus 1 upon sin theta multiplied by cos theta. This is nothing but our right hand side, and thus we have proved it. So these are some of the very important questions, and you should practice these questions again and again. Now note, in this very question, instead of this right hand side, it could have been 1 minus 2 sin square theta upon sin theta times cos theta. Now, in order to prove this, at this step, we would have taken slight change. Instead of converting sin square theta, we will convert cos square theta. Instead of cos square theta, we will write 1 minus sin square theta minus sin square theta upon sin theta multiplied by cos theta. And in the next step, this will give you 1 minus 2 sin square theta upon sin theta multiplied by cos theta. So this will again prove it. So we have to be very careful that what we have to get, and using the identities, the basic 3 identities which are very important, and for the sake of revision, I am writing here once again those 3 identities as summary. The first identity is sin square theta plus cos square theta is 1. In various form this can be used. If we have to use sin square theta, we can use 1 minus cos square theta, or cos square theta as 1 minus sin square theta, or cos theta as 1 minus sin square theta under root, and so on. There can be a number of combination of this. Similarly, second identity is 1 plus tan square theta is equal to sec square theta, and the third one is 1 plus cot square theta is cosec square theta. If you master these three identities, you are surely going to find this kind of questions, that is proving identities, easy. Thank you very much and good luck to all of you.